The first objective of this study was to investigate the association between bilateral subcortical volumes as measured by automatic subcortical segmentation performed in free surfer and polygenic scores for ASD for autism spectrum disorder, which is a measure of polygenic liability for the disorder. And to do that, we used linear regression modeling. So you can see here the formula of the linear regression that we used as a first test in our study, and we included the bilateral subcortical volumes as outcome of interest, and then we included the polygenic scores for ASD as principal predictor, and we added some covariates to take into account some confusing factors like the ASD diagnosis, sex, scanning site, because we have data available from 6 different scanning sites, and then dimensional measure of ADHD levels as indexed by the DOBA scores, and we included that to take into account the comorbidity effect of ADHD, because we know that there is a high level of comorbidity between ADHD and ASD. And then we also included covariates like age, full-scale IQ, intracranial volume, and the first 4 principal components to take into account genetic variance, so residual population structure in the genetic data. And we tested the simple additive model, and then we asked whether there was significant interaction effects between the predictor of interest and other variables like ASD diagnosis, sex, ADHD levels, age, and IQ. And what we found was that there was only one significant interaction effect that significantly improved predictive model, and it was the interaction between ADHD levels and the polygenic scores for ASD. And so this is the final regression model that we tested separately for each subcortical volume extracted through free surfer. So we had 8 different models. And if the effect of polygenic scores for ASD on the volume was significant, then we moved on to a second level of analysis in which we tested the so-called mediation model. So basically, what I showed you before was just this first step in the mediation analysis, in which we establish whether there is an association between polygenic liability for ASD and subcortical volumes, but we want to know how this works in light of the core symptoms of autism. And in particular, in this study, we were interested in the social traits as measured by the social responsiveness scale. And so we wanted to know whether the polygenic liability for autism could predict the social traits per se, but also whether this association was mediated by subcortical phenotype. And that's why we call this a mediation model. And this is tested through regression modeling. So the first regression I showed you before already, and then we tested the regression model in which the social traits were predicted by the polygenic scores for ASD, including all the different covariates that I showed you before, except for the intracranial volume, because of course in this case we're not taking into account the brain phenotype. And then we also tested these other regression model in which the social traits are predicted by subcortical volume, because if there has to be a mediation of subcortical volume on the effect of polygenic scores for ASD and social traits, then the subcortical volumes has to predict social traits. Then what we expect, well, we expect that there is an association between polygenic scores for ASD and social traits. And if the mediation is true, then adding subcortical volumes to the model, to this model, then we expect that the variance explained by polygenic scores would reduce at least, and we talk about partial regression now, or would just, there will be no variance explained, that there is no predictive power from polygenic scores when we include subcortical volumes. In this case, we have a full mediation. Otherwise, if there is no mediation, well, it just means that the polygenic scores have only a direct effect on social traits. So this is the scheme of the regression analysis in light of a mediation model that we performed for this study.